To display a 2-digits number using these 2 7-segments displays using the Arduino Uno board, we can reuse some of the developed code for the one display example. But to do the full implementation of this particular example, we have to learn a few more things. The first thing is the switch case structure that looks like this. The variable is an input to this structure, and its value is compared against each of the labels in the different cases. When the value of the variable matches the label, the statements of that case get executed. Notice that each case ends with a break line, which indicates the end of the statement. Since the Arduino Uno board does not have enough digital I/Os to command each segment of the 2 7-segments displays individually, we have to learn the concept of multiplexed displays. This means both displays are never turned on simultaneously. When one is on, the other one is off. To display a 2-digits number, let's say 16, we have to display the one on the first display for a brief period of time, turn off that display, and turn on the second display with the 6 also for a brief period of time. If we repeat this process, and then we increase the speed, we cannot see the flashing of the LEDs, we can just see a static number being displayed. Using this technique, we can use the same digital I/Os to connect both displays to the Arduino Uno board. And to select the display that will be on, we will use a switch. The particular switch we are going to use is called NPN transistor, which looks like this. It has 3 pins. The one on the right connects to GND, the one on the left to the common cathode pin, and the middle one connects to a digital I/O through a resistor. When writing a 1 in this digital I/O, the transistor powers up the display, enabling it. Because we have 2 displays, we will need 2 transistors and 2 digital I/Os to command them. Now we are ready to start working on Tinkercad. Here we have the 2 7-segments displays connected to the Arduino Uno board. The A segment of both displays is connected to the same I/O pin through a resistor. The rest of the segments are connected in the same way. And we have the transistors connected to the displays and the board. Since the circuitry is ready, we can start writing the code. We already have here some of the code developed for the one display example. We have the definitions for each segment of the displays, the configuration of the pins as output, the set LEDs function, and the function to display the particular numbers on the display. We included an extra function here to turn off all the LEDs in the display. So, let's start writing what is left. First, we define the word on as 1 and off as 0 to make our code clearer. Then we define D1 as 11 and D2 as 10. The pins 10 and 11 are connected to the transistors that command display 1, D1, and display 2, D2. Now, we will need to define 2 variables N1 and N2 that will store the numbers to be displayed in D1 and D2 respectively. Furthermore, have to configure D1 and D2 as outputs, and finally initialize the value of D1 and D2 as off. To write a particular number to the displays, we have to define a new function. It has to have an input with the number to be displayed. In the body of this function, we have to use a switch case structure. Its variable is the argument of the right number to display function. Depending on the value of the argument, we have to call the corresponding function to display that number. If number is equal to 0, we call the function 0 to display the 0 in the display. If its value is equal to 1, we call the function 1, and so on. Now we can start writing the code in the main loop. We need a for structure that will control the time period in which one number is displayed. We define an integer variable I and initialize it as 0. We will be in this loop until it reaches the value 250, and we increment it in steps of 1. I will explain the meaning of I equals 250 in 1 minute, but first, let's finish the code in the main loop. In the for structure, we first turn off all the LEDs, then we turn on display 1 and off display 2 using digital write. And we write the number 1 to the display 1 using the function write number to displays. Now, we wait 2 milliseconds, turn off all the LEDs, turn off display 1, and turn on display 2. And we write the number 2 in display number 2 using write number to displays. Once again, we wait 2 milliseconds. Now, what does it mean I equals 250? If we considered that these lines of code take much less time than the 2 milliseconds delays, then one number will be displayed 2 milliseconds plus 2 milliseconds times 250, which is equal to 1 second. Having clarified that, let's write the code that displays the numbers from 0 to 99 in the displays over and over again. For doing so, we first increment in 1, and if in 1 reaches a value greater than 9, the largest number we can display using 7segmentsDisplay, we reset the value of in 1 and increment the value of in 2. Then, if in 2 is greater than 9, it means that the number 99 is being displayed, and we need to reset both numbers. Now we are ready to test the code. Great, it works!